In our last lecture, we have discussed about the relationship between the load, shear force, and bending moment diagram. So, based on that understanding, today we're going to draw the shear force and bending moment diagram for the a plane frame, plane portal frame for the various support conditions. So, before that, we should understand the what is free body diagram. So, free body diagram means what are the reactions it can take or the deformation, what are the deformation is possible for each node, that is called a free body diagram. So since it is a plane frame, in a single plane we going to have a two translation, one is horizontal, another one is vertical, and one rotation. If in case of a space frame, we going to have a three translation and three rotation for each node. Today we are going to discuss about the only plane frame. So each node going to have a three degree of freedom, two translation and one rotation. So uh, to understand the concept easily, now I am going to discuss about the two different support condition for the same portal frame. One is one end is pinned. Pinned means it can take the vertical reaction as well as horizontal reaction, and the another support is a roller support which can take only the vertical reaction. If load is applied in horizontal direction, it will free to move, it will not give any restraint. So another case is both end is pinned. So basically if we have the roller support here, when you apply some loading shown here, this will deform similar to the black color dash line. Suppose if we have the restrainment here as well, so our deformation diagram going to be something like this. So uh, you can see some number with this some example. Actually here I have applied some 1000 kN load as on the W equal to 1000 I considered in the analysis. If you see here, since it is arrested in both horizontal and vertical direction, there is some rotation, but the translation is itself zero. Whatever the value we are seeing is the translational deformation in mm. So if you see the vertical beam, that is also get deflected almost 386.5 mm, and the right support is moved almost 732 mm for the 1000 kN load. So the length considered in this exercise is each element going to have the 5 meter. In case of a pinned support in both end, so if you see this 732 mm deformation is arrested, so the diagram going to be similar to this 0 0, and the deformation is going to be some number. We should know the shape of the deformation diagram. It's not necessary to know about the values. If any analysis you are going to do, so after getting the result we should judge the engineering judgment is very important based on the deformation shape and the shape of the shear force bending moment diagram. We have to understand that whether that software can give any result whatever the load or some support condition you are giving, but that it will give, but whatever the result we are getting, that is correct or wrong for our structural arrangement, that we should take the engineering judgment, we should take that our, that is our responsibility to understand that. So we are discussing all these things. So now based on this deformation diagram, and if you see the this, even though it can take both horizontal and vertical reaction, since it there is the other support is not able to take any horizontal reaction, as per the equilibrium equation sum of force will be zero. If here zero, this is also going to be zero, so it cannot take. That is why if you see this element, these two vertical element going to have only axial force, it's not going to have any bending and any shear force. But in the horizontal element it is similar to simply supported beam condition, so it have that two vertical reaction and one loading, so it going to have the bending moment and shear force diagram similar to the simply supported beam condition. But in case of the another support conditions where we have restraint in both vertical and horizontal direction. So because of this loading, so already we have seen that. So this 732 mm deformation is zero. What it is telling us is like there is some restrainment, so definitely there going to be some reaction. So this reaction will be equal and opposite to this reaction anyway. So both vertical element now going to have some horizontal loading. So because of this loading, it's going to have some shear force and bending moment diagram definitely. So small change in the support conditions, how it is affecting our the entire shear force and bending moment diagram, that we will see with the numbers. Now let's consider the case one where we have one pin and another roller. So since already we discussed these vertical elements are just like a support only. It's going to have only axial stress. It's not going to take any bending moment or shear. So these joints also going to behave like a pin only. This pin directly you can put here. The same. The only difference, whatever the reaction we are going to get here, the direction is transferred through this particular element. It's reached here. That is the only difference. Even though it is a portal frame, it's behaving like a simply supported beam only. So the deformation already we have seen, it's similar to this. And if you draw a bending moment diagram for this free body diagram, so here whatever W, so W by 2, W by 2, so from here gradually it is increasing. So the maximum bending moment diagram going to be here. Again, because of this reaction and this loading, it gradually decreasing and it's going to reach here. So this bending moment diagram is exactly similar to the simply supported beam subjected to the point load, and the vertical element is not going to have any bending moment diagram. It's going to have only pure axial stress. And in case of the shear force diagram, already in last lecture we have discussed that shear force means nothing but it is the rate of change of bending moment. So since this slope is constant, our shear force diagram going to be a straight line similar to this. So it's going to be W by 2 from here to after loading W. So W by 2 minus W going to be minus W by 2. It will go up to here. After that it's 0. So our bending moment diagram going to be like this, and the shear force. If you see this diagram, it's exactly representing the point load applied at the midspan of the simply supported beam, even though it is a portal. So if in case of both the hand pinned, how it's going to look like? Since this can take, if you take consider only this diagram, if I take the bending moment diagram from this point to this point, move from here to there, so let's say some reaction going to be here, let p it's going to gradually increasing the moment diagram and it will reach maximum at here. This moment will be going to be equal to this. Since this joint is in equilibrium, these two moments are equal and opposite. Same way this vertical reaction going to be this vertical reaction but opposite sign. Same this axial force is going to be shear force for this element. So this is the deformation diagram, already we have seen it. So bending moment diagram going to be as we discussed. Here it will be 0 since it is pin. So gradually it is increasing. It's going to attain some bending moment. These two bending moment going to be equal. And so here again so there will be some bending moment. So the diagram going to be similar, look like this. And in case of the shear force diagram, same way, since this slope is constant, we going to have a rectangular shape of shear force diagram. Same way here also the slope is constant. Here one rectangle and again load another rectangle, another rectangle. So this is how it's going to look like the bending moment and shear force diagram for the both end pinned portal frames. So come to the summary. Now this is the portal frame. The one end is pinned, another end is a roller. So this is that some software we used to analyze to see the number so that we can understand better way. So here if you see 0 0 reaction and only vertical. So 1000 load become divided into equally to, since this load is applied at the midspan, 500 kilonewton, 500 kilonewton. If you see the bending moment diagram here, 1250 kilonewton, here 00 kilonewton. So these vertical elements going to have 0 kilonewton meter moment. So shear force also, this is 500, here 500. There is no shear force on bending in the vertical element. It's it's purely behaving like a simply supported beam. These two just an compression member, no shear force, no bending moment. In case of both end pinned, same. Now we are seeing some 75 kilonewton horizontal reaction. This 75 kilonewton going to have some bending moment and shear force. So if you see this bending moment diagram, this 75 into already I told that this is 5 meter height. So 75 into 5 it's going to be 375. So that is the number we are seeing here. So this is the bending moment diagram, and the same 375 going to be here, and because of this loading there will be some reaction, so 500. So if we consider the free body diagram for this element alone, so you're going to have now the difference, only the difference is because of this end is restrained here 875, here 375. If you put together this 375 and 875 going to be 1250. So what it is telling, because of these two different conditions, now the moments are redistributed. There is, if a sum of moment is the same, 0 plus 1250, so 1250. Here 375 plus 875, it is same 1250. The only difference is this will be more economical because our moments get reduced. So maybe what we have to do in the detailing, we have to do here less compared to here. Here there will be less reinforcement. Here we have to put some additional reinforcement. Basically, this is the concept of redistributions. In case of shear force also, if you see here, this vertical element going to have the 75 kilometer reaction is there, right? So no other load in between these elements. So here it starts 75, it's complete entire height of the column going to have 75 kilonewton shear force. In the horizontal element going to have this reaction 500. So from here to here 500. After that the loading 1000 going to come. So minus 500. So it's become zero, something like this. Maybe in another video we will see if it is the support is fixed and the other support is one case is fixed, another case is pinned, and another case is roller. Then how the diagram going to change, that we will discuss in detail.